first video in our complete AP Calculus course. The beginning of this course is going to focus on limits, which are a fundamental topic to understanding the remainder of this calculus course. So, without further ado, let's get started. Our first topic is limits to infinity, meaning the limit as x approaches infinity, and this is the common notation. This represents the limit of f of x as x approaches infinity. And what it's asking us is, what value does f of x, that is the y value, approach as x approaches infinity? In other words, as x gets very large. So let's take a look at a few common cases. Our first case here is a very simple parabola. And we can see that as x gets very large, as we go to the right on the graph, the parabola is going to extend infinitely upward. Now, we have no reason to believe that that pattern is going to change in any way. So we can conclude that the limit as x approaches infinity of f of x, in this particular case, is positive infinity because it's going to get infinitely large with no upper boundary. A second case would be something like an asymptotic hyperbola. So here we can see that we have two asymptotes. And we can see that as x gets larger, this is not in fact going to infinity. It seems to be converging toward the x-axis. The y value of the x-axis is 0, so in this particular case, we could say that the limit as x approaches infinity of f of x certainly appears to be 0. And a third case, where we have a function that seems to be going downward. And again, it's a parabola, and we have no reason to believe that it's going to hit any sort of a boundary. So here, the limit as x approaches infinity of f of x, it seems to be going toward negative infinity. So those are three graphical examples. In our next video, we're going to tackle some algebraic examples.